Alright everybody, so just like I did for the insertions in the red-black trees, I thought we would go through an example step by step of everything we need to do when actually removing something from a red-black tree. We went over all of the rules and all of the cases, but it definitely helps cement things when we actually go through this step by step by step just to see exactly how this works out. Right, so what we're going to do is we're going to start off with basically this tree that you see right here on our left side. It's a fairly good sized red black tree just to get things started off with. And the first thing we're going to try to do is we are going to delete the node 40 from this tree. Right? So if you were going through this in your code, you would just start off just like you would normally do with any other binary search tree. Right? And when you do that, you're going to find the location of the node that you actually want to delete, and you can go ahead and you can start basically checking it to see, okay, what case is this going to fall under as we're going on here. Right? And as you can see, our node that we want to delete is basically a black node, and that node also has one red child. So if there's any case that this is going to fall under, this is actually going to fall under case 2 that we had talked about, right? And case 2 basically just says you can go ahead and you can delete the node and move its red child up into the position it was at, and then recolor that node to black, right? And the recoloring part is very important here, because this is the aspect that lets us keep the black height of the tree. If we did not recolor this 50 from red to black, then we would no longer have a valid red-black tree. We would be violating the rule of the red-black height of the tree. But by changing its color to black, we keep that rule and everything's good to go. So now let's just keep going with this example. And the next thing we're going to do that's actually going to cause quite a few things to happen is we are going to try to delete 50 from this tree. Okay? And we're going to see the kind of chain reaction that this makes as we work through it. Alright, so again, just as you would do before, you would search your tree for 50 to see if it exists and where it's at, and then you would start, looking at its current situation to see what needs to be done. Alright, so of course 50 is right here, and we can start looking to see what kind of case is 50 going to fall under. Right, and when we try to delete 50, we're noticing that we are deleting a black leaf node from the tree. And what happens when we delete black leaves from the tree? Right, we know that this is going to affect the black height of the tree, and this is likely going to require some restructuring to happen. Okay, and when this happens, this is where the whole aspect of a double black comes into play. Right, so we can delete 50, but we're going to need to make a special case and mark that we now have a double black in the tree that we need to resolve. Alright, so I'll just bring this tree copy back over here. We have now deleted 50 from the tree, and we have replaced 50 effectively with this double black. And again, I'll signify a double black basically with this double barred arrow that you see here. Just put up, and then just its null node. Okay, so now the rest of the operations that we're going to perform are really going to be done in order to try to resolve this double black. And if you remember from the previous video, any double black situation that we have is going to basically fall under one of the case 3s that we talked about, right? We had 3 separate case 3s, A, B, and C. And in order to judge which one of those we use, we need to look at the double black sibling. Right? That's going to determine exactly what the color of the sibling and what color the sibling's children are is really going to determine what action we're going to take in order to try to resolve this double black. Right? So if we look at the double black sibling, we're going to see this is a red node, right? So this is actually going to fall under case 3C, right? And 3C was the case where we rotate left or right around the double black's parent, and then we go ahead and do some recoloring in order to try to make things work out. Right? So because our double black is on the left side, and this is case 3C, we are actually going to end up rotating right around the double black's parent. And that is again because the double black is on the right side. If the double black was on the left side, we would rotate left, etc. Right? So when we rotate right around the parent, we're going to get a new tree that looks something similar to this. So again, remember, because we're rotating right, the parent's left child will take the place of the parent. Right? So 15 is going to come up and become the new root here. And then 15's right child is going to become 25, which was the old parent. And then 25 is going to have, it, of course, its double black child that we're trying to resolve. And then 25 is also going to get the right child of 15. So this guy right here is going to get attached to 25 instead of 15. Right? Effectively, 25 and 15 are swapping places when we're rotating here. So we will just move him inside. And I'm really lazy, and I don't want to draw that all, so I'm just going to do this. Put that there, copy him in, and we're good to go there. And then, of course, 15 will still have its left child of 10. And then 10 will go ahead and have its two null children. Right, so he'd go there, and then he'd go there. Right? So we've rotated, but we're not done with the requirements for this case quite yet. Right? After we rotate, we need to do some recoloring in order to try to finish up exactly what this case tells us to do. So if we're going to do some recoloring, the exact recoloring we're going to do is effectively going to be, we're going to color the new parent black, and then we're going to color the old parent red. Right? Pretty straightforward. Alright, so new parent is going to get colored black, and then the old parent, which was 25, is going to get colored red. Okay, so we've done our coloring, and now the big question is, are we good yet? Are we done? Are there any other things we need to do? Which, if we look at this tree, we're actually not done yet, because what did I mention in the previous video, right? A black node cannot have a single black child, right? Because this throws off the red-black balance, or the black height of the tree. If we check our black heights, what we're going to see here is if we start at the root, we'll get to we'll get one black node, and then 2 to get to the leaf, right? So we have a black height of 2 there. If we try to count over to our double black, over here, we would actually, if we would remove the double black, we would just have a black height of 1, and then if we tried to get down to here, we'd have 1, 2, right? So our tree is still not meeting all of the rules of the red-black tree, right? Which means we need to look back, and we actually look, and we cannot remove our double black quite yet. We need to keep going with some more operations in order to make this all work, right? So if we keep our double black, we again go and look at its new sibling to see exactly what case we fall under. Right? In this case, our new sibling is black. Right? So when our new sibling is black, we can go and look at our cases and decide what's going on. Right? So we have two potential cases. We could go with case 3A, or we could go with case 3B. If we look at the cases, case 3A actually says if the sibling of the double black node is black and has a red child, then we can partake in this one, right? So our double black is here, its new sibling is 20, and 20 has a red child. So this means that our new case that we're going to work with is now case 3A. And under case 3A, basically what we're going to do is we're going to do another rotation around the parent, and then we're going to do some more recolorings, and then after this second rotation, our tree should actually be in a good state. All right. So if we go, hold on one second. All right. So this time what we're going to do is we're actually going to do yet another rotate right. However, this time we're rotating right around this 25 right here, because the 25 is the parent of our double black node. Alright, so we're going to rotate right, which means our 20 is going to end up coming and taking the place of the 25, and then we're going to move the 25 down. Alright, so our new tree is going to look something similar to this. So 15 will still be the root of the tree, 10 will still be down here, and 10 will still have its 2 leaves. We just mark off here. And now, because we rotated right, 20 is taking the place of 25. And then 25 has moved down here. And 25 still has the double black node coming off of it. 25 will inherit basically the right child of 20, which has moved up to the top. Alright, so that means 23 is going to move over here. And it will have its null children. And then the left child of 20 will still be 17, like it had been before. And of course 17 was red. And then 17 has its 2 null children. Alright, so now we have our rotated tree. However, we can see there's still a few things kind of not right here. Alright, because for instance, we have a red child with a red child, which of course breaks the rules, but luckily we are not done with case 3a quite yet. Okay, the end of case 3a basically has some recoloring rules that we need to go through. Right, the first rule being we color the new parent the same color as the old parent. So actually, let's just go through these 3 recoloring rules together. Alright, so step 1 is basically recolor the new parent, which is 20, the same color as the old parent. So that means 20 is going to become red. Then after that, we color the old parent and its new sibling black. Right, so both of these guys, 17 and 25, will become black. And then at this point, if we look at the tree, we've now fixed our double red child problem. And if we start looking and counting the black height of the tree, everything should actually work out now, right? So if we start at 15 and try to get to these leaves down here, we got 1, 2, so a black height of 2 there. To the other leaf is a black height of 2. If we want to get down to the leaves of this tree, we'd basically go 0, 1, 2, so black height there is 2. If we want to get down to the leaves at the bottom, down here, we follow our path, and we have a black height of 1 and 2, so that works out. And if we wanted to get to this node, we would have a black height of 1 and 2. Right, so by rotating the tree twice and doing some recolorings, we have actually now basically been able to resolve this double black. So now that we have reached this point, we can go ahead and remove our double black, and now our tree is now in a good state, right? So that right there is a pretty in-depth example of exactly what would happen in a single delete operation in a red-black tree. Again, just like the insertion example, You know, if you want to keep going with this or you feel like you're not quite comfortable with it yet, keep just picking random nodes from this tree and deleting them. And try to follow all the rules, and at each step verify the current state of your tree. Verify that no red children have red children, verify the black height works, etc. You know, just to check your work and make sure you're getting a good understanding of this. So with that, if you have any questions about what I drew on here, please let me know. Don't hesitate to send me an email. And with that, we'll see you in the next video.